HVAC gals and guys. Today we're going to be talking about contactors, their purpose, the function of them, and we're going to be testing them in continuity and resistance. I know this is a basic component. We may all know these basics I'm about to go over today, but it doesn't hurt to reiterate. So we're going to start off by what is a contactor? A contactor is an electrically controlled switch. You know, when a voltage is applied to the coil, the contact points will close. So a contactor is an electrically controlled switch at its bare definition. When the voltage is applied, low 24 volts to the coil, the contacts will then close. Its job is to let a low voltage signal for 24 volts safely control high voltage power such as 120 to 208 and 240. You can think of this as like a gatekeeper. When a thermostat calls, the gate opens. When the thermostat is satisfied, the gate closes. Contactors are important because they keep high voltage out of the thermostat. Just imagine if you had all of those wires that go to your contactor wire netted together. That would not be good. It also protects the system from constant power draw. It allows safe automation of the condenser, compressor, and your fan. Now, the sequence of operations of how a contactor works is the thermostat calls for cooling or heating. 24 volts is sent to the contactor coil. The coil becomes a magnet. The magnet pulls the contacts closed. High voltage flows to the compressor and your condenser fan motor. The thermostat is satisfied. 24 volts stops. The contacts opens and the system shuts off. Sorry about my missing screw. Main parts of a residential contactor is your 24 volt coil. You'll see right here how the coil is wrapped around there, right there, and right there, and underneath there. Give you some more examples of an older one. Why this is not, you would not check this, of course. This is just there. You would check this right here, and you confirm that by the winding going up into this part right here where your 24 volts should be. It's all leading back to here, to here. And of course you have your L1 and T1 on this side, and you have your L2 and T2 on this side. L1, T1, T2, L2. You have your load side. I'm gonna keep reiterating this for you guys. It does matter. This is your equipment, T1 and T2. L1 and L2 is your line from your disconnect. Okay, and your load side is T1 and T2, the power to your compressor and your fan. So the contacts, they move open and they move closed when energized. Open, closed, open, closed. For your single pole contactors, you would check L1 to T1. You would not check this side. You would only put your leads right here and right here. Check first when it's in the open position, then you'll check when it's in the closed position. For your double poles, you will go from L1 to T1 and L2 to T2. Single pole versus double pole. A single pole contactor switches one circuit. A double pole contactor switches two circuits. This makes a double pole contactor essential for controlling hot lines in a 240 volt system, providing a more complete electrical disconnect for safety. Now we're going to move along to how to test a contactor in continuity and resistance. Of course, for this, the tools you will need is your multimeter, and you will switch it to ohms and continuity. If you stick around, I have that video separate at the end of the video, so I wouldn't break it up and confuse anybody. But of course, safety first. You never test continuity on a live circuit. You also visually inspect before metering. You will check for burned or pitted marks. Burned or pitted marks on your contacts melted plastic, a chattering or buzzing during operations. Any of these equal replacement of the contactor. You don't want to walk up and hear a zzz. If you think there are bees are around and you don't see any bees, it's time to change that contactor. So when you test the contactor coil for resistance, you'll always set the meter to ohms. You'll place the leads on the coil terminals. Typically, the reading should be between 10 and 20. That will be good. If you read OL or infinite reading, that is an open coil, that is bad. If you get a 0 ohms, that's a shorted coil, it is bad. Not a 0.0.1 or a 0.0.0. If you get a 0, that is bad. In the video, I will have a thumbs up and I will have a thumbs down to give you different scenarios on good coils and good contacts, bad coils and bad contacts. When you test high voltage contacts, you do that for continuity. So this is the coil going across. This is the contact, the high voltage for your contacts. You meter between L1 and L2, T1 and T2, but not in that order I just gave you. So it'd be L1 and T1, L2 and T2. You should read a OL, no beep, when it is open. And you should read 0 to 1 beep when it is closed. So when it is open, you shouldn't get nothing. No beep, no nothing. But when you push it in, you will get between 0 to 1 ohms and you will get a beep when it's closed. If resistance stays high or no beep when it's pressed down, the contacts are bad. Common contactor failures are coil burned open, the coil welded down, the contacts welded down, the contacts are pitted and resistive, it is insects or dirt preventing the movement. It can be some beetle bugs in there. It can be a lot of things, but just make sure you don't overlook something like that. Now, when to replace instead of test. I always emphasize on testing. I know you may be in a rush sometimes, but just to get in the practice of things, if you want to skip testing, when the contacts are badly burned, buzzing loudly, the unit will not shut off, or repeated intermittent failure, then you can just replace the contactor instead of testing it. But for a beginner tip to remember, coil pulls, contacts close, power flows. The coil pulls, contacts close, power flows. When that thermostat sends the 24-volt signal, the contacts close and the power flows. So the coil will pull from that 24 volts, contacts close, power flows. If the coil is good but contacts fail, you guys, you need to replace the contactor still. If coil is bad, replace the contactor. They are not repairable parts. Lastly, for your key components, the coil is energized with a specific voltage, creating a magnetic field that actuates the contactor. For your contacts, these conductive parts open and close the circuit. Contactors typically have normally open and normally closed contacts. Now, the moving part of the contactor, drawn in by the coil's magnetic field, causing the contacts to change state, is your armature. If you guys stick around to the very end, after I show you some testing of resistance and continuity, you know I always have your cheat sheets for you, so take your screenshots and save it in your gallery so you don't waste your time coming to TikTok, going to YouTube, or calling that supervisor. I hope this helps. So let's do a little inspection together. You never judge the components by how they look. You always go thorough and deep with your inspections. Now, how pitted contacts look, I hope my focus does not mess up, but as you can clearly see, you guys will have to get something cute like this. You got to get in there. Don't be scared. Do not do this on live equipment. Do it while it's isolated. That is how it looks when it is pitted. If it looks like that on the top and the bottom, it is time to change it. Now, also, sometimes you can noticeably see that it's burned. But yes, check the top and bottom to see if those contacts are pitted. That's a very good one right there. See if I can get you some more. Yes, look at all that. You can see that before I even pick it up, y'all. You can see that's top and bottom. It's coming all out. Yeah, that's how it looks when it's just nasty and it's time to go. So yes, that is how it looks when your contacts are pitted. They have that rough, rocky, unsurfaced, and you always check the top and bottom. But sometimes you can see from right there, but get you a little cute flat head, lift it up, check the top and bottom, and see if those contacts are pitted. Right here, you don't see anything. And from our testing, we did not get a good reading when it came to the contact. It did look a little pitted at the bottom, but not like the other ones. And just like this one was a bad one, we can clearly see that we don't see any silver. So always lift it up and check if your contacts are pitted. We are good. Pushed in, we are good. Pushed out, we're good. Pushed in, we are good. L1, T1 when it's pushed out, we're good. L2 to T2 when it's pushed out, still good. L1 to T1, this is not good. L2 to T2, still not good. Try one more time. So when it's inconsistent like that, either it's severely pitted or it's something that's making the contacts not contact how they're supposed to, because it's inconsistent. So I think you guys got the gist. If you were to put your leads right here and you're not manually pressing it down, that means it's already stuck closed down and it's already reading. That means that it's not a good contactor unless it is having a call from the thermostat. So we're going to go from L1 to T1 on another contactor. From L2 to T2. And this one is good. If the resistance stays high or you get no beep, then the contactor is bad. I'll give this as an example. Let's check the other side. Let's try one more time. I gotta get me a head camera. And I'm pressing down as hard as I can. Bad contactor. Bad contactor. Until y'all get it. last but not least, I love showing you guys good and bad. So sorry if the video is a little longer today. This one is good. It's hard doing this with one hand. This one is good.